Welcome to this session. I'm David Pilato, and I'm developer at Elastic, also evangelist. I'm working on Elasticsearch and plugins in Elasticsearch. At Elastic, we are building this stack where you have ingest layer, so basically ETL, where you can extract data from a source, transform the data on the fly, and load that to a system like Elasticsearch or other system. So with Logstash, you have also bits. We are going to talk about bits now. Elasticsearch is an index engine where you can, so you send data to Elasticsearch as JSON documents. Elasticsearch will store the data, index the data, and give you some nice APIs which will help you to search for your data and also analyze your data in real time. And we have Kibana, which is an end-user interface on top of Elasticsearch, which helps you to understand what your dataset looks like. We are providing also a set of commercial plugins about security, if you want to add security on top of your stack, alerting system, a monitoring system, reporting, like you can generate PDF documents every day, for example, or after an alert. Also a graph API, which helps you to connect documents all together, and the most important document, not all the documents. And we are providing all that on Elastic as a service, which is Elastic Cloud, where you can deploy all that thing really easily. And we are building those days Elastic Cloud Enterprise, which will help you to deploy all that stack also within your company on your on-premise or on your AWS credit if you have some, or Azure or Google Compute Engine, whatever. So let's talk about bits. Bits, what are bits? So bits are lightweight shippers that collect and ship all kinds of operational data to Elasticsearch. So important terms here, lightweight shippers. What does it mean? It means that you install those bits as agent on your servers. They are written in Golang, so you don't have any runtime dependencies, and they are really lightweight. Then they collect and transport data to Elasticsearch. What kind of data you can have? For example, you can have data which is coming from the wire, you can have system statistics coming from your system, or you can have logs as well, for example. If we look at wire data, we have one of the bits we have is named Packetbeat. So it basically helps you to sniff the network traffic between your client and your server. You basically install the agent on your server, and then without needing to modify your application, you can, using Wireshark, and you can index any protocol that Packetbeat is aware of. How does it work? So it captures the network traffic, it decodes the network traffic, then it can help to correlate the response with the request, so you can have you can build response time really easily. And then it creates a JSON document which contains all that information, and send that to Elasticsearch. Packetbeat works with many decoders, such as HTTP, MySQL, you have the full list here, Postgres, and so on, and we are adding a lot of other decoders already. The community also is adding a lot of them, and you can add yourself a decoder. Metricbeat, it's like running the top command on your system. So every 10 seconds you have a top command running, and you are collecting the response from this top command and send that to Elasticsearch. You can get access to some system information like the load, the CPU usage, and so on. You can have a view per process. So what is the name of the process, its state, the command line, the usage in terms of CPU and memory. Also about the disk usage. So what are the disks available here, and what is used, what is the free space, and so on. Filebeat helps you to basically tail a file, a log file, and index the content to Elasticsearch. One of the cool things with Filebeat is that it communicates with Logstash, for example, with using this back pressure sensitive protocol, which means that anytime Logstash cannot really deal with all the contents Filebeat is sending to a Logstash, Logstash is telling to Filebeat, okay, please slow down a bit because I can't manage to deal all that thing. And Filebeat will slow down. It's super easy to implement because we have log lines and we can use this file as a message queue system. We just have to point to the line we are currently and just keep the other message coming in this file. And then when Logstash is available again, go to the next lines. That's super easy. With Filebeat, you can so parse your logs with Logstash. Then with Logstash, you can send your logs to an archiving system. For example, if you want to archive on S3, just send that to S3 with a S3 Logstash output. And you can also send them to Elasticsearch, which is going to index the logs. I didn't mention, but in Logstash, you can do some transformation. For example, you can say, I want to use regular expression to analyze my line of log, so my string, and try to create how can I say that? A structured document from that. For example, if you have an error code, I want it to be an error code in my JSON document. So you are going to use what we call grok filter for that, which is a library of regular expressions. Then you can say, oh, I have a date, but the date within this document has a specific format, so I'm going to use a date filter in Logstash. And then you have an IP address, and you want to understand where on the planet the attack is coming from. So you are going to use a GeoIP filter in Logstash, and Logstash with this GeoIP filter will extract from the IP address and will give you back the coordinates of the corresponding to this IP address, so latitude and longitude points. With Elasticsearch 5.0, you can do that even more easily. If you have a simple use case, like I just want to tail a file and understand what I have in this log file, you can use what we call ingest in Elasticsearch 5.0. And the filter I just mentioned as part of Logstash, you can find some of them inside what we call as ingest node processors. So the grok, GeoIP, date, and some of them, you can find them inside Elasticsearch. So basically, you just stream your line of logs to Elasticsearch. Elasticsearch will do the enrichment and then index the document. That's it. So you won't have to monitor Logstash anymore. We have also WinLogBit. So WinLogBit is like the equivalent of the Filebeat we have seen before. It works even with Windows XP, so really old versions. And then you can again send your data to Elasticsearch using ingest or to Logstash to parse the logs themselves. Let's have an overview of the bit platforms. So anytime you are writing a bit, you are using what we call Libbeat. I'm going to explain in the detail what you have with Libbeat. So any bit will help you to send data to Elasticsearch, and then something you can visualize within Kibana. And then you can send also your data to Logstash and send to Elasticsearch, and then explore with Kibana. Bits that Elastic is building and community bits are all based on this Libbeat library. So what we have inside, we have inside Libbeat we have a config management part. So it means that anytime you want to add bit configuration, so this is coming for free, debugging, filtering, for example, maybe some lines, you don't want to send some lines to Elasticsearch. For example, I don't want to send all the 200 error code to Elasticsearch. It doesn't make sense. I just want to send errors to Elasticsearch. So you can filter lines. This is coming as part of Libbeat. Command line handling. the logging to files, syslog, and so on. Outputs, so you can output to Elasticsearch, Logstash, obviously, but now you can also output to Redis and Kafka if you want. So this is coming natively. Then you build your bit on top of that. And you have also a test part. I didn't test the test part, but probably easy to use. We are also providing what we call a bits packer. Packer? Okay. Because bits are binaries, you have to provide a binary for each platform you are targeting. So for Debian, Ubuntu, Windows, and so on. So this bits packer repository will help you to create, using Docker, will help you to create all the binaries you need. This is the best music of the world, right? If you like this music, you are probably as old as I am. 44 now. It's cool. Okay. Why this music? Oh, because of the name of the talk, and also because I coded a bit myself just to play with Libbeat to see what is it actually. And the name of this bit is Soonbit, and the goal of this bit is to analyze MP3 music and try to display that in Kibana. So I want to show you all that. Let's do that. So I need to share my screen first, of course. I already started locally on my laptop an Elasticsearch instance. And okay, so I have Elasticsearch here. It's complaining because I don't have enough free space, but that's all, not an issue. And I started also Packetbeat. So it's super easy to start Packetbeat. Okay, sudo Packetbeat, done. I also started Metricbeat. Easy as well, right? I started Kibana locally here. I also started an application that I wrote. This application, I will use this application to send data to a SQL database and try to monitor what is happening. And then we will see Soonbit. So what do I have? If I look at Packetbeat, for example, for now, so I'm in Kibana here. I'm looking at the overview. Okay, I should just auto-refresh that. Okay. So I have no traffic for now. I told you that I have an application here running, so basically it's trying to search in a database. Here I have nothing in the database, but I'm sending some search requests, so I'm hitting my web application. This web application is sending requests to the SQL server. Okay. If we look at Packetbeat now, okay, we have seen that we have some transaction, so database transaction here, and web transaction. This is what we have. Not really interesting for now. Let's inject some data. I'm going to inject 10,000 people, so those are people generated randomly. If we look at Packetbeat now, probably, yes, we can see more things happening. So as you can see, I didn't change my application. I just have to monitor what is happening on the network card. That's all. And I can look. Yeah, 15 minutes. It's okay. Okay. I can look closer. For example, I want to see what is happening on the web transaction part. So this is an overview. If I look at the web transaction part, I can see that I have some API calls here, so get API 1 init status and get API underscore search. Yeah, no errors, that's fine. I can generate some errors. For example, let's call a URL which does not exist. Okay. I just need to auto-refresh that. Okay. So now I can see that I have some errors here. Okay, let's do some null pointer exceptions. So I have a specific endpoint in my application when I can generate null pointer exception. Don't do that in production, but this is okay. So I'm generating 500 errors here. And if we look at Packetbeat now, okay, I can see that I have those errors. If I want to filter, this is a typical Kibana thing. You can click here and say, I want to see all the error 500 codes. And this is the URL where I have those errors and so on. Super easy. If we look at MySQL, I'm using MySQL as a database here. Okay, we can see some result. Let's zoom in here. So I have a given number of set, select, commit, update, insert, and so on. The response time. What is interesting here is that I can see directly what are the slowest MySQL queries I have seen during this time. So that's super easy. Okay, let's have a look at Metricbeat. So Metricbeat is running here on my laptop. So I have this overview. I was already there. If I look at the load, CPU, I can see that, okay, the CPU increased a bit during that time. Probably I was doing the injection in that period. And if we look at the processes, we can probably see here something interesting. Whoops, too much. Let's go back. A bit less, like this. Okay, so we can see some spikes here. So probably what is that? CPU usage per process. So yeah, the Java part is the most important. That was my application running. And what? I was expecting MySQL, but it's okay. It's after. Okay. Let's have a look at Soundbeat now. So I wrote a new bit called Soundbeat. To do that, I use what we call cookie butter. Cookie butter is helping you to create a bit using a template. So basically, you write cookie cutter and the repo name you want to configure, and then it will ask you some questions such as what is your name, what is the name of your bit, and so on, and it will create all the skeleton for you. And then you will just have to edit all that stuff. I'm not going to edit all that stuff live because I don't have enough time to do it, but I'm going to explain what I did to code Soundbeat, basically. So one of the first files I edited was the config file. It was coming only with the duration by default. I just added a name. So I want to analyze the MP3 file. So here I'm providing the name of the MP3 file. I can define some default values. And I have also this bit.yaml file, which is a sample. So it will be the default sample file that will be provided as the configuration file for my bit. So this part of the file, here I added the name part, for example. This part of the file will be merged with all the settings you need to communicate with Elasticsearch, for example, and this will create a bigger YAML file, which is the actual final configuration file. So it will create that, so your part, and then it will add all the things you need to communicate here with Elasticsearch or to communicate with Logstash. Okay? So just edit this one, and you will get back this one. Then, the code itself now. So what I added here in that code, I added those two lines, those two imports. I need to do some math. And I'm using here also a library named Socks. So Socks is a library running on my laptop. It helps you to analyze sound files. And Go Socks is a wrapper on top of that. I didn't change anything here. I just changed here the new function. So the new function is called when you initialize the bit for the first time. So you get back the config. And here I'm just checking that I have a name set. Otherwise, I'm giving an exception. I'm initializing the socks library I mentioned before. And that's all. The important part is the run part. Okay. So the run part is called just after you have initialized your bit and everything is set up. So it comes by default with your client. So this client is able to connect to whatever destination. So it can be your Elasticsearch, Logstash, Redis, Kafka. With socks, I'm opening the MP3 file. And here I'm doing some math, basically. So what I'm doing here, I'm trying to compute the duration. And I will send an event to Elasticsearch from now to up to the duration of the MP3 file. So if I have 5 minutes of MP3 file, then from now I will generate a bit, depending on the rate you choose. So I think I choose, yeah, for every 10 milliseconds, I want to send something to Elasticsearch. So here some computation. With socks, I'm getting back a buffer, and this buffer basically will contain, sorry, I can say that, a value for the left channel, for the, what do you call that? The amplitude, the value, the level of the left part of the signal and the right part of the signal. So I'm iterating over this buffer, which contains all the samples, and then I'm saying, okay, from now you are just going to move 10 milliseconds later, then on the other iteration 10 milliseconds later, and so on. Then I just need to get back the sample, and I have to use this modulo to get the right part or the left part of the signal. So here I'm just building internal stuff basically. And the important part is that one. Here, this is where I'm building my JSON document that I want to send to Elasticsearch. So in this document, I will find the timestamp, which is my now value. So now plus 10 milliseconds, now plus 20, and so on. The name of the MP3 file, and then the value for the signal. I am multiplying by 100 here, but okay, not mandatory. This is what I'm doing here. And once my event is ready, I'm going to publish that event to Elasticsearch, Logstash, Kafka, Redis, whatever. So you just have to implement that, basically. Create a client, do your stuff, create an event, publish the event. Okay. In Packetbeat, this won't stop until you press Control C, right? But here I'm just quitting after the loop and say, okay, I'm finished and I'm done. And you have a stop method where you can close whatever you want if you need. You just have to compile that. It will give you and provide, sorry, a binary. So here, if I look at the binary, is this one. Okay. And you just have to launch it. This is my binary. Okay, done. If we look at Kibana now, let's do normal things in Kibana. If I go in Discover and say I want to look at the last 15 minutes, I can see that some samples are coming. Yes, obviously I'm starting to index from now and I'm indexing into the future. Okay, but let's, yeah, and we can have a look at the samples we have generated. If we look at the JSON document here, can I zoom a bit? So those are what bits is creating. We can see again our left value, right value, and the type. Okay. What we can do next is to visualize all that. So let's do that. With Kibana, we have a plugin named Timelion, which is coming now by default with Kibana version 5. With Timelion, you can deal with time series. And what we can see here, here it's only printing what we have in the Elasticsearch index, all indices, sorry. But we want to look at only what is happening in the Soonbit index. Okay, we can see that we have some documents coming. I can zoom here. And let's say that I want to go in the future up to 22. Okay. And okay, that's fine. And let's make that bigger. Okay, so I have the count of documents per bucket, which is not super interesting. I can have a better visualization if I'm using bars here. Okay, so now I have a bar. Okay, not super interesting. What you can do, you can call what we call aggregation in Elasticsearch to compute some aggregation and some metrics, for example. So to do that, you can say, I want to compute a metric, and I want to have the minimum value for my left part of the signal, so for my left field. Okay, I have the left value now. Interesting. Can we have the right? Let's add a new time series. And we say, okay, I want now to have the right part. Okay, I have the left, the right, but they are overlapping. So I'm going to multiply this one by -1, okay, to have the inverted thing. But the bars are stacked all together, so I need to tell TimeLion, don't stack the bar. Okay, it's looking like a MP3 waveform, right? And then you can save that, add that in a dashboard inside Kibana, and do whatever you want. Actually, you are not going to use that in production. It's just for the demo, right? And I'm done. If you have questions, I have 3 minutes left. Yeah.
Actually, you could use that in production to do dynamic range of songs. It shows the lowest sound compared to the maximum and show the amplitude of the sound.
Yeah, so if we can do that to see the difference between the minimum and the maximum value, yeah, you can do that. And we can do that here also, instead of using min and max, min, sorry, I can use here, for example, max. Max on the right bar. I'm going to stack them and not multiply. I can do that, and then I can do here, take the two series and do a subtract. So this is the difference between the max and the min. Any other? 2 minutes.
Does Filebeat handle the log file rotations?
Yeah, so does Filebeat handle the log file rotation? Yes, it does. So yeah, totally.
Just like Logstash?
Yes. So if you knew Logstash Forwarder, so Filebeat is basically the replacement tool for Logstash Forwarder. It's really more efficient than Logstash Forwarder. Yeah, works well. Filebeat? Bit? Okay. So is Bit compatible only with Elastic version 5? No. So Bit started with version 1, which is compatible with Elasticsearch 2, probably version 1 as well of Elasticsearch, I guess. So it started a long time ago, and we just try to normalize all the versions names. So now we have a version for the full stack. So that's the reason we call that Elastic Stack version 5 now, because it comes with Kibana 5, Elasticsearch 5, Bits 5, and so on, and Logstash 5, obviously. Yeah.
Those Packetbeats have support to inspect TLS, stating from the fact that you give the right keys.
I'm not sure about the answer. So there's a Packetbeat support TLS and SSL, basically. I don't have the answer, so I don't want to tell you bullshit. In worst case, we can index with Packetbeat what is the size of the data we have seen and the response time. This is the worst case we can do. But about the content itself, I'm not sure. We are done. Thank you.